Hi, welcome. Today we're going to be exploring how we can improve our development team's productivity and enable them to ship features to market a lot earlier using OpenAPI and mocking. Before I do that, I'm going to cover off a few definitions before we get going. So when I'm talking about API driven or API centric architectures, I'm really talking about microservices or service oriented architectures or environments where there are a number of third party integrations. So you communicate with APIs outside of your organization or infrastructure. In these types of architectures, new product features often require changes in multiple of those services, or sometimes new services entirely need to be built to meet the needs of those new product features. Now, in these types of architectures, this can lead to a real web of dependencies where producing teams are required to build and ship something before consuming teams can even begin to think about starting or building their features. So this really increases the time it takes to get new product features to market, and this is something that we would want to improve. I think in any organization, this shipping features sooner, getting value into the hands of our customers can only be a good thing. So to perhaps highlight this, I'm going to talk about this hypothetical system architecture. Now you can see the boxes in the middle and to the left. These are microservices. The box on the right is our application. Could be a web app, or it could be a mobile app or something like that. But that's the component in our system that delivers the value to our customers. Now you can see the lines between these individual components. These are API calls essentially. So essentially showing the dependencies that each of these components have. And you can see that the SSO component and the inventory component are the ones that don't have any external dependencies and are just relied upon by other components in the architecture. So if we take a look at this maybe from like a hypothetical kind of sprint-based way of working, we can see that in sprint one, we can complete the SSO component. The dark blue in this diagram are completed components, and the light blue are work in progress, or actually being worked on at this point in time. So you can see that we can start the inventory because it has no dependencies, and we can start at least part of the app and customer profile because they rely on a component that's already been finished. We move into sprint two, and more of those in progress components are finished, and new components come online. And it's important to realize that maybe different teams own each of these components. They're not necessarily all built by the same team. So we have different teams waiting on components from other teams to be finished before they can even begin the work that they're scheduled to do. And as we move through, we move into sprint three, more gets completed. And as we move closer and closer towards the value that our customer is hoping to see, in sprint four, we finally finish the app. But as you can see, it often works almost backwards in this scenario, where the thing that actually delivers the value to our customers is a thing that actually gets finished last. So before I kind of move on much more further, I'm going to kind of introduce the concept of mocking. Now, I think most people watching this video will have experienced mocking in some shape or form. But for those who haven't, I'll kind of give a high-level overview. So here we have a client and a service. The client relies on the service, so has a dependency on that service. Now, given the scenario we just spoke about before, service A would have to have been shipped or at least partially started and partial functionality shipped before the client could start. So with mocking, we're essentially trying to do something like this, where we provide a realistic or real enough mock of service A that we can use, so we can essentially start the work on client B alongside service A. And that mock will essentially walk and talk exactly like service A, to the point where the calling client won't know whether it's speaking to the mock or it's speaking to the service. So this obviously has a number of benefits. Like I said, most importantly, we can build these two components in parallel to each other. We've mocked out service A, so there's no longer that hard dependency to actually start the work before client B can be started as well. There are lots of mocking tools out there. Some are open source, some are SaaS, some are free, some are paid. What you're seeing here is a screenshot of the mocking tool from WireMock, the company that I work for. In a few minutes, I'm going to hopefully be giving a demo of how we might use WireMock to allow multiple things to be started at the same time, and how we can use mocks to accelerate that development process. So essentially, what are the benefits? Mocks are quick to build, much quicker than the actual things that you're mocking. So they can be available almost immediately, depending on how you build your mocks. And as I mentioned before, there's really no need to wait for producing teams to build and ship something before those consuming teams can start their work. And perhaps one of the more important benefits of mocking is that it gives you that early feedback. What we find is that when you're designing an API, that design is essentially unvalidated. It's only when you start to build against that design or interact with that design that you really start to kind of iron out some of the kinks in how it works. And with mocks, you have that ability to build against something right from the start, or at the very least just interact with it to see how it feels, how it works. And you get that early feedback, hopefully before the producing teams have started implementation and made some what could be quite costly kind of implementation decisions or implementation mistakes. So let's go back to our hypothetical sprints and system architecture. You can see in sprint 1 that we've now started more of the work. More teams can kick off the work building the components because we've essentially mocked all of the dependencies within our hypothetical architecture. And we move over to sprint 2, and you can see that everything has been finished. We've now moved the dependencies away from the mocks to the real system. So we've essentially halved our build time, halved the amount of time that it takes to get new features in the hands of our customers. Now this can be a little bit of a contrary example, but you kind of get what I mean, that we're essentially reducing that dependency on real things being in place so we can ship faster. Now, I talked about OpenAPI right at the beginning. So how does OpenAPI relate to mocking? There's a number of things you can do with OpenAPI. I'm pretty sure most people listening to this will have used or come across OpenAPI in the course of the work that they do. It is essentially become the kind of ubiquitous standard for describing REST or REST-like services. So in relation to mocking, there's a number of things you can do. At the very kind of basic level, you can take your OpenAPI specification and you can use that to generate your mocks. And some tools, WireMock Cloud included, you can use your stubs. If you take maybe a mock first approach or an API prototyping approach using mocks, you can then use those mocks to generate your OpenAPI specification. So you essentially have the other way around from generating mocks from your specification. Some tools allow you to do essentially the round trip. You change your spec, you then change your mocks, and if you change your mocks, it then updates the specification. Again, some tools, WireMock Cloud included, allow you to validate traffic against your mocks against the specification that's been used to generate those mocks. So you effectively get a source of contract testing. Clients can be built against those mocks, and as they're being built, you can then validate the traffic that gets sent to them. So again, improving the kind of speed which things are built correctly. However, there are a few caveats, I think, to using OpenAPI with mocking. I think the first one is that OpenAPI was never really or never primarily intended to be used for mock generation. So it kind of lacks the vocabulary to describe the nuances of implementation that you would want your mocks to adhere to. It means that when you generate your mocks from your OpenAPI, they tend to be overly simplistic. They kind of follow the happiest of happy paths. So they're great from a first iteration perspective, but in most cases, you would want to then iterate over your mocks and implement behaviors that the OpenAPI specification just isn't or doesn't have the vocabulary to describe. So to hopefully demonstrate this workflow of using mocks to kind of aid development, I'm going to give a demo, and the demo is based on an OpenAPI specification by the kind of bump.sh team. And the OpenAPI describes a hypothetical train travel API, so you can book trips and things like that. And this OpenAPI is complex enough that it provides a good source for a demo, but not overly complex so that it becomes a little bit unwieldy and kind of hard to get your head around. So let's see how that would work. So what you're seeing here is the train travel demo app that the WireMock team built based on the OpenAPI specification from the bump.sh team. And you can see that you can go in and book trips and essentially pick a date, and it will return some trips. Now, at the moment, when you first visit this this app, it's based on a WireMock Cloud mock API that's fully featured and fully developed. Now, for the purposes of this demo, I've taken a completely new mock API. And this is what you're seeing here is WireMock Cloud. And there are no stubs in this OpenAPI at all. And just to give you a little bit of background, a stub in WireMock is a unit of work. It represents a request response pair. So when a request comes in, it will get matched to a stub, and then that stub will define what happens, what response gets sent back to the client. So this is completely empty. So what I'm going to do is I'm going to take this new mock API that I've created, and I'm going to update the app to use my mock API instead of the one that was there before. So if I refresh this page, you can see now the app is essentially broken. There's no stations, there's no nothing. If we perhaps take a look at the network tab, you can see that this stations endpoint returns a 404 because there's essentially nothing in the mock API. So how do we start generating our mocks? Now here I've got a copy of the OpenAPI specification that we're going to use. And so I'm going to take a copy of that, go back to our mock API. And this in WireMock is an OpenAPI based mock. So that means that we get access to the ability to add an OpenAPI specification, and we have the ability to update stubs when APIs change, when the specification changes, or update the OpenAPI based on when stubs change. So I'm going to take this OpenAPI and just paste it in here and save. So all being well, we should now have a number of stubs generated automatically from the OpenAPI specification. And you can see, for example, if I find the stations endpoint, there's both XML and JSON in here, but if I find the stations endpoint here, you can see that we have some data in there that has been purely generated from the examples in the OpenAPI specification. So if I go back to my train travel demo app now and hit refresh, you can see that we've got that data coming through into our app. So we've instantly generated mocks from an OpenAPI specification to facilitate testing of this application. Now I can select a station and pick a date, and it returns a couple of trips based on the data that was in the trips endpoint for the OpenAPI. Now, we mentioned before that the first iteration of mock generation from OpenAPI can be a little bit simplistic, and we see that here. It doesn't matter what station I pick, whether it's the same one, what date I pick, we get the same results back in our trips search. Also, perhaps less desirably, if I select a date in the past, we still get the same data. So that's not really how our real system would work. So let's take a look at how we can perhaps update our mocks to facilitate testing that feature. So let's pick a date in the future, and let's go back to our mocks. So we'll essentially be looking at the trips endpoint. If we find the JSON endpoint. So first thing I'm going to do is I'm going to delete this stub because these match criteria are overly specific, and WireMock has already generated a generic or default stub for us. So I'm going to delete that. But before I get into the kind of success response, I am going to take a look at this stub here. Now, this is the one that generates a 400 request for that trips endpoint. Now, the first thing I'm going to do is I'm going to increase the priority of this stub. And what that means in terms of kind of WireMock is if all things being equal, a stub with a higher priority will match a request first, then a stub with a lower priority. So what I want to do is I want to delete this header matcher, and I'm going to add a query parameter matcher. And I'm going to base it on the date query parameter. And I'm going to say the date must be before, pick a relative date of now. So we're essentially saying that this stub will match if a request comes in that has a date parameter that is before now. And we might want to update this message here to say the date must be in the future. So I'll save that. And all being well, I can go back to my train travel demo. And if I pick a date in the past, I now get an exception shown to the user saying the date must be in the future. So effectively what we've done there is we've kind of leveled up our mocks to facilitate the testing of a feature that just our auto-generated mocks couldn't deliver. So next, I want to take a look at how we are able to generate better responses than just the default data for the trips. So here I'm going to use a feature of WireMock Cloud called data sources. Now, what you're seeing here is an example CSV file that we've uploaded into our data sources in WireMock Cloud, courtesy of ChatGPT. And this just describes a number of trips to and from different stations. So I want to take the 200 success response for the trips and utilize that data source. So I'm going to say I want this stuff to be based on my train trips data source. And the first thing that we see here is this what's called a where clause. Now in WireMock Cloud, we access data in the data sources based on like an SQL where clause. And I've got that here. And you can see hopefully here that this where clause ties columns in the CSV file to elements in the request. So we're basically saying the where clause ties the origin column to the query parameter origin and the destination column to the query parameter destination. So I'm going to take that, I'm going to pop that directly in the where clause here. And then you can see here that we've got the default test data that was just generated from the example data in the OpenAPI. So I want to make that dynamic. And to do that, I have some response pre-defined here. And hopefully what you can see here is that this is not a static response. This has WireMock response templating embedded in it. And it effectively iterates through the data returned from our data source and sends that result back to in the response. So I'll take that, copy that. We'll enable dynamic response templating for this stub, and we'll save that. So we have the data source enabled, we have dynamic response templating, so we can save that. So if I go back to the train travel demo, we can see that before I do, these data source has a number of stations in there that we don't have in the default data. So what I'm going to do is I'm going to copy this list, again, courtesy of ChatGPT, of stations that tie via their IDs to the data in our data source. So I'll take that. And for this one, we need to find the stations endpoint that we looked at the beginning. So this one here. And we'll take that and we'll just paste that directly in there and save that stub. So if we refresh, you can see that we now have a much broader range of stations. And if I can remember which two stations it is, Barcelona and Brussels, maybe not. Let me just have a look at my notes. Budapest to Brussels. There we go. So if we select Budapest to Brussels, you see now we get a totally different response back than just the default data that was generated from the OpenAPI spec. So once again, we've kind of just leveled up the ability for our mocks to provide a much more realistic environment for us to test against and for us to interact with. Now that's all I want to cover in the demo for today. One thing that I would do if I was to take this to kind of level up once again is I would probably take a look at the my bookings tab. Here again, as we've already discussed, this is just displaying data that was generated from the OpenAPI examples. So it's not in any way tied to a booking that we might actually do through this interface. WireMock Cloud has the ability to use dynamic state. I'll show you the kind of UI here. But if you go and take a look at the at the train travel demo, this will all be built in the mock API that you can interact with. So what that means is that a trip that we book through our demo application gets put into state, and when you retrieve that list of bookings, it pulls the list from the state. So one API call effectively changes the results that get returned from a different API call based on our mocks. So that's kind of where I would take that, and definitely something worth investigating if you're playing around with WireMock Cloud. So hopefully what you've seen throughout the course of that demo is that we can use OpenAPI really, really well in terms of generating mocks. They provide a great starting point, but they tend to be quite simplistic and based just on static data. But with the right mocking tool, you can essentially kind of keep leveling up your mocks to provide better and better lifelike features for the APIs that you're mocking and facilitate a much broader range of testing scenarios. All of this kind of goes towards helping our dev teams work in parallel and ship features to our clients and get value in their hands much more quickly than they would do otherwise. So thanks for watching. I hope that's been of some interest, and hopefully we'll see you in the kind of WireMock community soon. Thanks. Bye.